there. Okay, so first thing I want to mention is that there's going to be an SL review, so a final exam review session. You guys know what SL? Yeah. Unknown. So there's going to be 2 sections or 2 sessions. You're allowed to go to both if you want to. It's on Monday the 17th, so the day before our final. Okay. There's 1 session between 3 and 5 and 1 between 5 and 7. They want you guys to sign up if you plan on coming. You're allowed to drop in anyways, but if you plan on coming, because that's how they'll figure out how many people to hire to host it. And so, yeah, so 8 people is 1 person. More than 8 people makes 2 people that they have to bring in. So, so they just want to get an idea of numbers. If you're not sure if you're going, I probably wouldn't sign up. I would hate for them to think there's, 16 people coming and only 7 show up, right? So, if you're for sure gonna show, then sign up. I'll just pass it around. You're welcome to sign up for both, sign up for neither. It's no skin off my back either way. So, but it is a really good review session. They just have extra practice problems and stuff to go through. Yeah. The room is unfortunately TBD. I wish they had it all figured out, but it depends on how many people sign up. So it's open to all the Math 114 sections. So there's an SL review or final exam review session. Oops. Great, got a solid. Yeah, it's from my other section. Maybe 3, no? I'll send out the details anyways. So I'll send out an announcement with the room and remind you of the times, right? Like I said, you're welcome to just go. It's just they need to know if roughly how many are going. December 17th, room is, oh, TBC, what's that? TBD. There's going to be 2 sessions, one from 3 to 5, and the second one is from 5 to 7. And I gave you guys my office hours last day, right? All day on the 18th and in the afternoon of the 17th. Okay. Cool. All right. So you probably have maybe have your notes from last day. We got through the compound interest problem, right, with the unknown payment amount. So we'll just pick up on the compound interest problem that we have to do by hand. I think you might even be disappointed with how simple it is. Like, what? By hand? That's supposed to be scary. I know. Which question is it? This one here. Oh, I need to grab the, oops. Okay, so even though we've got kind of weird numbering on here, but question 20. So we want to know what's the value 1.5 years from now, right? So from today, of the following payment stream using a 4.1% monthly compounded rate of interest. So a payment 1 year from today of 15,000 and a payment 6 years from today of 2,000. all calculations must be done without the help of the time value money functions of your financial calculator. So you have to show your work by hand, right? Of course, you're allowed to check your answers with your calculator, right? That's encouraged even, right? But as far as showing all your work, you have to show your work by hand. Okay. So, oh, I guess I was putting the type here. This is a compound interest problem by hand. So first thing we need to do, right, is figure out how many ticks we have. Okay. So because all of these time points are referencing today, we're going to put today on there. Okay. And then we want to know the value at 1.5 years from now. And then we've got a payment 1 year from today and 6 years from today. I'm counting 4 ticks. Right. So let's get those on here. So we'll start today. And then in order, right, we had a payment 1 year from today. We want to know the value at 1.5 years. And then there was another payment at 6 years. It says years, but years. Oh. So let's put our amounts on here. So we've got 15,000 a year from now, and a payment 6 years from today of 2,000. I'm also going to highlight that this is compound interest, right? So that's how we know there's only one simple interest problem, and it's going to be among the first few, right? But it's just good to highlight it. So we want to know the value 1.5 years from now, right? And so to do that, we have to use 1.5 years as our focal date. There's no other option because we want to know what's the value of these two at 1.5 years, right? And so we're going to pull this forward to some future value, this back to some present value, and then the total here is going to be the total value 1.5 years from now. So call this future value 1. 1 is just denoting the order of the calculations. Doesn't matter in this case. Present value 2. Add those up and you'll have the total. Right. Total value 1.5 years from today. So next thing we're going to do is put our ends on our arrows, right? So our ends in this type of scenario, we're back to the number of compoundings, right? And so we've got, let's just make a note here. We said we have R is 0.041, and the frequency, the compounding frequency was monthly. So the number of compoundings, N, is time times the frequency. Between a year and 1.5 years, there's only half a year, right? So don't be thrown by it being at 1 year or anything like that, right? You want to look at the distance of this arrow in time. So half a year times a frequency of 12, 6. How about for this one? So between 1.5 years and 6 years, right, we've got 4.5 years of monthly compounding. So n is time times the frequency, which is 4.5 times 12. Oops. Which is 54. Need this soon. Okay. So let's find I. I is R over F, 0.041 over 12. Point 0.0341666 repeating. Of course, I'm going to store this in 1. If you had to use your calculator to solve this, do you remember what we did with just these normal compound interest problems? We set the payments per year and the compoundings per year to the same value, and then we just plugged in 0 for the PMT, right? So that's how we do these problems on your calculator. And we'll see a couple in a bit, but just a heads up. Because that was back when you guys didn't like your calculators so much. It's like, oh, we were so foolish. But now I think you've changed your tune. Okay. So, all right. We got to find the future value, right? So future value 1. And most important thing is that you remember that you're just in this kind of original compound interest. We've got compound interest, of course, in the annuities, right? But if we've got regular payments, that's when we have an annuity. Here, I really don't know what to call them because I call them compound interest problems. Does that make sense to you guys? Even though they all have compound interest? Anyways, we've got our future value is our present value times 1 plus I to the power of n. Oh, things were just simpler back then, hey? Now we've seen big monstrous problems. So our present value for future value 1 is the 15,000. So we're finding how much would 15,000 be worth 6 months later. 1 plus 0.003416 repeating to the power of n, which is 6. Yeah, I've got these Martha Stewarted. I'll just steal them from here. 15,310.14. I unfortunately rounded to 2 decimal places right away, but it doesn't matter. It's what we have to do. Next thing we're going to find is present value 2, right? The value of that $2,000 6 years from today, 1.5 years from today. So 2,000 is our, oh, got to write down my formula that I'm about to use here. We've got our future value over 1 plus I to the power of n. And because these are on your formula sheet, you don't have to derive them. So we're safe. Now we've got 2,000 over 1 plus 0.003416 repeating to the power of 54. $1,663.56. So then the total value, 1.5 years from today,
Makes me think of a cooking timer. It's like, the eggs are ready. Future value 1. I should have said something cooler than eggs, but
Cookie.
peek into my life, I guess. Like, oh yeah, eggs are ready. 15,310.14 plus 1663.56. Total value of 16,973.70. That's it. So as far as doing it by hand, even though it kind of sounds scary, oh, you have to do this one by hand, I think we're all kind of okay with doing these ones by hand, right? There's going to be, I mean, it can't really change much from something like this. I'm going to see, can you calculate a present value? Can you calculate a future value? Great. Right. So the amounts can change. Well, they will change. Times will change. But in general, I'll just make you calculate a future value and a present value, add them up, total value. Okay. So nothing too crazy. Any questions about that one? Here's the second by hand one. There's only 2, right? That you have to do by hand. But this is the annuities by hand. So now we're moving into annuities. So if we just have a quick peek, so Herbert decides to invest $1,000 at the beginning of each month, right? So now he's making these regular payments of $1,000 each month, right? And so that makes it an annuity. Okay. So we've got an annuity, and just skimming through, do all calculations without using the time value money functions of your financial calculator. So it's an annuity by hand. So let's see what we've got here. So we can start with our timeline here. Herbert decides to invest $1,000 at the beginning of each month. Right? So we know for annuities, we have to have our start and our end point, and also 2 points in the front and 1 tick in the back. I guess I could have spaced them out a little bit more. Oh well. And they're at the beginning of each month. So we've got 1 month here. Well, this is today. 2 months. And then we need to know what the end point is. And so if money earns a rate of return of 4.5% compounded annually, what amount should Herbert expect to have in his RRSP after 10 years? Okay. So let's just highlight the things that we usually do. So the payments are at the beginning of each month. So beginning, so we have an annuity due in this case, because the payments are at the beginning. And the payment frequency is monthly and the compounding frequency is annually. So just make a little note of that. Okay. And so the end point here is 10 years. So we need to know how many months in 10 years. We'll call it 120. Making this 119 months. Da, da, da. Do you guys remember how we indicate on our timeline that we have payments at the beginning of each month, right? Usually if it's at the end, we start a payment here, payment, right? If they're at the beginning, we just shift them over 1, right? So we start today, and then keep going until that 119th month. So we write 1,000, 1,000, 1,000, and 1,000. So what amount should Herbert expect to have in his RRSP after 10 years? So how much are all these payments worth 10 years from now? Right? And so we're gonna loop these, and they all funnel back to some future value due, right, at 10 years. Because we have to take into account that all of these were at the beginning. On our arrow, right now we've got an annuity. So our N is the number of payments, right? So let's just make a note here. So we've got payments at the beginning. Our payments per year is 12, and our compoundings per year is 1. Right? So our payment frequency, we call it F2, right? And our compounding frequency is F1, and that's always true. So N is the number of payments, which is going to be time times technically F2 if you want to kind of decipher it, because F2 is the payment frequency. So here we've got time, which is 10 times 12. I'm willing to overlook if this is missing, as long as you've got this here, right? Because they're going to always be the same, right? As long as you're showing, if you've got monthly payments, you're showing months. If you've got bi-weekly payments, you're showing, I've got 500 bi-weeklies, right? Something like that. You've got it here. So, or if you prefer to show it here, just to kind of map it out what it is and then put it there, that's fine too, right? But as long as you've got it there, I'm okay with that, right? Whereas before, I had to have it on the arrow, yeah.
How do you know if you use the future value formula?
So due, an annuity due, means that you have payments at the beginning,
Okay.
right? So when you've got these payments at the beginning, you have an annuity due. Yeah. All right. Oh, what else do we need on here? Okay. I think that's all the questions asking. Right. We have to do this by hand, of course. So we have to calculate I2 because these frequencies are not the same. Right. So next up, I2. First, we need our rate, 4.5%. So 0.045. I1 is R1 over F1. 0.045 over 1, which is still just 0.045. It's okay. It's like time to wake up. Or
Reminder for appointment I have after. Don't forget.
No worries. So even though the I1 calculation is a little bit not needed, I like to just do the same thing over and over again, and then like, oh, I didn't need it, whatever. Better safe than sorry. 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.045 to the power of F1, which is 1 over 12 minus 1. That's what I'll do. So we've got, oops, 0.045 plus 1 to the power of 1 over 12 minus 1. I get, bless you, 0.0036 74809, which I'll store in 1. So we know we have to calculate a future value due, right? And so we've just got to use our future value due formula. Future value due is the PMT. Make sure you're not looking at the wrong one. I know I get mixed up, but my eyes jump around a little bit. But got to be careful. 1 plus I to the power of n minus 1 over I times 1 plus I. So the amount of the payments is 1,000. And we have 1 plus 0.003674,809. Or, like I've said, if you want to just call or write recall 1, fine by me. Well, that's fine. As long as you told me you stored it in 1. Over 0.003674,809 times 1 plus 0.003674,809. Pick up speed towards the end. Writing it out is actually longer than just doing it on your calculator, but we have to do this one by hand, so well. Plus 1 to the power of 120 minus 1 divided by recall 1. I'll do a little pit stop, show my work here. You don't have to. If you want to go straight through, that's okay. So I get 150 for those big brackets, 150.4756,741 times 1.003674,809. Get $151,028 and 0.6435. He would have $151,028.64. Nice. So again, compared to what you have been doing with these annuities by hand, right? Thinking back to test 3, for example, where I made you do that huge question by hand. This is not so bad, right? And then the rest of the annuities questions, you're allowed to use your calculator. In fact, I encourage you to use your calculator because it's going to make your life a lot easier. Okay, any questions about that one? No? Okay. Oh, speaking of that big question from test 3, the last one where you had to do it by hand. This one's gonna feel very similar, except we're allowed to use our calculator now. I think I called this something like a 3-part annuity or an annuity. It's an annuity question with 3 parts. You'll see what I mean in a second here. I kind of talked about it last day, right? So imagine your that last question on test 3, right? Where you've got, he's making payments, and then we transition right away to getting payments. Now, so I would call that a 2-part question, right? Because there's payments here and payments here. Now, what we're saying is we're going to make payments for some amount of time, and then whatever we have saved is going to sit there for some amount of time, and then we're going to get payments, right? So we've got this kind of gap of a few years or whatever that we need to take into account as well. Okay. But because we can use our calculator, it makes it a little bit easier. Okay. The hardest part is going to be mapping it out and figuring out what you need to do. So you'll need lots of room for this one. I know I'm gonna run out because I'm cramped on here. So let's just read it through, see what's going on. So you've decided to invest in your RSP over the next 23 years. Okay, so for 23 years, you're gonna make payments into your RSP. Okay. You intend to make bi-weekly contributions over this time period, with the first one beginning today, right? So that's an annuity due situation, right? When you retire in 30 years, right? So we're only making these payments for 23 years, and then you're going to retire in 30 years. Keep it alive. So 30 years, and then when you retire, you would like to receive $1,500 month-end contribution, so that's just an ordinary annuity, for the next 25 years, right? So all in all, we're going, so he retires in, well, we make payments for 23 years, retires in 30 years from today, and then 25 years of payments after the 30 years, right? So overall, we're going from today to 55 years, right? However you want to map out these years, I don't want you to stick with whatever I say for the 55 years. If it makes more sense to you to put 25 years, that's okay, right? Because this stuff can be hard. Oh. Ta-da. So I'm gonna put 55 years kind of up higher here. So we've got 23 years. So I'm just putting my years up above, right? Because I've got my bi-weekly contributions, and then I'm getting month-end contributions, right? So I'm not going to be talking in years that much. Okay. So then I'll just make a little note here that between here and here, I have 25 years. Okay. So we know for these regular payments, right, we have to have 2 extra ticks in the front, 1 extra tick in the back. So let's just draw those in. 1, 2, 1. Like I said, it's a little crammed. And then no payments between 23 and 30 years, right? So nothing's happening, but whatever we've got saved at 23 years is going to be earning interest, but just regular compound interest for 7 years. Right? And then at 30 years, we're going to get 1, 2 ticks and then another tick here, dot, dot, dot. So bare bones, this is what we've got going on. Okay. So you're going to make bi-weekly contributions. So in 23 years, you're going to have how many bi-weeklies? Times 26. You've got 598, oops, 598 biweeklies. Oops. You know what? Start over. I'm just write BW, biweeklies. So this is 597 biweeklies. Here's 1 biweekly, 2 biweeklies. And then the question is, what biweekly investments should you make over the next 23 years? So we want to solve for this payment amount. So in terms of the structure of the question, it's very, very similar to test 3, right? It's just got that gap between 23 and 30 years. So you intend to make biweekly contributions with the first one beginning today, right? So we start our payments here, payment here, and a payment here. No payment at 598, right? Because we're shifted over. Now let's move to the payments that we're getting, right? Starting at 30 years, we want to get $1,500 a month end contribution. So we've got 1 month, 2 months, and it's okay to just reference from the 30-year mark. Otherwise, it would get so confusing. Right? How many weeks after or months after today? No. As long as you remember that the length of time here is just 25 years, not 55 years. 25 times monthly is 300 months. So this must be 299 months. So we know these payment amounts. You're going to receive $1,500 a month at the end, so month end contributions. So 1,500, 1,500, 1,500. So just like on test 3, if we want to end up here, we have to take what we know from here, right? We can figure out what that's worth at 30 years. So whatever this has grown to at 23 years, in turn has to grow to this amount in order to sustain these payments. Right, so we've got kind of this, I don't know, kind of a snake calculation, right? Because here, these guys are going to map back to some present value, right? And then, but this amount is the future value of this guy, right? So we're going to find the present value. That's going to be equal to the future value. And then we can find the present value at 23 years. And that's the future value of the payments. Like I said, that's probably the hardest part of this question, is figuring out what is what. Okay. So what it's going to look like is that you've got payments. Give myself some room here. These are all going to funnel back to some present value. I'll call it 1. These are going to be equal to some future value 2. A future value because we can map it back to some present value 3, which is equal to, just looking at these payments here, some future value due 4. There's only 2 numbers, right? Because these are the same, right? But we first have to find this, and then we say, okay, well, now that I know this, that's the same as this,
Right, it has to be. So now I can use this number to find this value. Right? And then I use that value as the future value due. And once I have this amount, right, the amount that these payments are worth at 23 years, then I can solve for the payment amount. How about this for a deal? You don't have to calculate the I2s. That would be nasty of me. Lots of I2s. 2.5. And a half? Yeah, the compound interest gets just an I1. Just for our own kind of sanity, let's write out our little summary that we usually do. So for this first section, so I'm going to deal with them in sections. Okay. So, I'm just mapping out. So just my beginning or end, the payment frequency and the compounding frequency. They are. So I'm doing like an imaginary kind of don't know why they couldn't be straight lines,
Yeah.
but in my mind, they could not. So for this section, right, we've got how many payments per year? We're making payments bi-weekly, so 26. And we're compounding. Oh, here's another thing. Are the interest rates the same or, oh, how nice of me. On test 3, right, you had 2 different interest rates, right? I know, I'm so nice. But now you've just got one interest rate, 8.25%, compounded quarterly. That's nice. So 8.25% compounded quarterly. That's going to be the same for all of these. Here, you only know that you're compounding quarterly. I guess I should move that down. So we're on the same level here. And then here for this last section, we're at the end for our payments, right? Our payments are at the end of each month. And then our payments per year are monthly, so 12, and our compoundings per year, still 4. Okay. So my lines aren't so long. And I went with straight lines this time. Not as fun. All right, so let's make little notes to ourselves here. You don't have to, but I'm just talking you through it, right? So first we're gonna find PB1, right? Which will then be equal to FB2. Okay? So first find PB1. And let's just use our calculator. Okay. And interest per year, present value, payment amount, oops, future value, payments per year, compoundings per year, and I've just shortened it to B/E, beginning or end. For present value 1, right, we said we're at the end. And I think this is the confusing part, right? Because we're used to working from left to right, right? So we want to take the information from the first section, but we actually have to start at the last section, right? So keep those straight. So we've got our payments per year is 12 and our compoundings per year is 4.
The interest per year is going to be 8.25% for all of these. The future value of these payments that we're getting, well, when we've run out of money, we've run out of money. So 0. And the payments that we're getting are $1,500. If we're receiving this money, it's going to be positive, right, for our calculations. If we have to give it away, right, pay it off, it's going to be negative. The positives and negatives are going to switch as we go through. They actually don't, I hate to say they don't matter for this question. No, because we're just gonna treat each case separately. So it won't actually matter because we'll just drop the negative and just use the dollar amount, right? We've seen some cases where, like on test 3, where it did matter, right? We borrowed some amount and then we forgot to make the payments negative. Then we just keep borrowing those payment amounts, right? So that doesn't make sense. But in this case, so what's happening here is, okay, so we're getting these payments, which means we had to pay this amount, right, in theory. Which means we had to get this amount, but we had to pay this amount. So it just gets a little bit weird. I wouldn't worry too much about it. I'm not going to be hung up on the positives and negatives for this question because they do get confusing. I'll do them, but if you go through and you get the same answer, you're all good. Yeah. So the present value is the one we want to solve for, and our N here, we're getting payments for 300 months. Just to emphasize, I'll just put N is 300 here, and N is 598 here. The only thing that's missing, right, is the N for the regular compound interest. Yeah, what the hey, let's just, our compounding frequency is 4. N is time times the frequency, which is, so time is 7 years times 4. So we've got 28 payments. Compoundings. I messed it up. It's the same, but I said payments, but there are no payments there. It's compoundings. Confusing. And for this one is 300. 300, 8.25, 1,500, 0, 12, 4, enter. Make sure you're at the end, and then I compute present value. So I get a present value of negative 191,154.2953. Therefore, technically, present value 3, right, has to grow from whatever it is to 191,154 and 30 pennies. Right? So therefore, present value 3 must grow to 191,154.30. making that future value 2. So for this section, right, we know the future value and we want to find the present value again. But now we don't have any payments, and so our calculations look a little bit different, and interest per year, present value. In the past, I've joked about getting stamps, mostly because stamping is pretty fun, but also it'd be really convenient. Just, oh, I need a little table here. So now we just found this amount, which means we know this amount. So now we're going to do our calculations for getting this. Yeah. So we said we have 28 compoundings. Our interest per year is the same, so 8.25. Our present value is the one we want to find. Our payments are 0. Our future value must be, I'll just make it positive, 191, 154, 30. Our payments per year have to be the same as the compoundings per year. Our compoundings per year is 4, so payments per year must be 4. And we're at the end, but it shouldn't matter. I do want to make some notes, right, because it's been a while since we looked at just regular compound interest on our calculators, right? So this is the number of compoundings. No payments. And must be equal to the compoundings per year, both of them. All right, 28 and 8.25 interest per year, 0 for the payments, 191, 154, 30 for the future value, and then payments per year 4, enter, should keep the compoundings per year the same. And then we can compute present value. So the present value I get is a negative 107,927.0766. So whatever our payments are, they have to equal $107,927 after 23 years. So now that we know how much they have to be equal to, and we know how many payments we're making, we can calculate our payment amount. So therefore, our payments must have future value due. Did I put the 4 equal to 107,927.08. So, and interest per year, present value, payment amount, future value, payments per year, compoundings per year, beginning or end. Our N, number of payments, 598. Our interest per year is still 8.25. Our present value, we're starting with 0, right? So at the beginning of all this, we have 0 present value. And then we're trying to find our payment amount, and we need it to equal 107,927.08. And we made notes of it up here, 26 payments per year and 4 compoundings per year. And they're at the beginning. Don't forget that. Okay, here we go. 598, 8.25 for good measure, 0 present value. 107,927.08 future value. And 26 payments per year, 4 compoundings per year, and need to change it to the beginning and then compute PMT. We have to make payments of negative $61.07248259. He must make payments, or bi-weekly payments, of $61.07. Nice. For 23 years, and then when he retires in 30 years, he'll get payments of $1,500 a month. It's not bad. Pretty good. Tough for us to get 8.25%, but in theory, that's how it works. Any questions about that one? No? So this next one is also an annuity question. I'm calling it kind of a 2-part annuity question. And this is the one that we haven't seen besides in class. So it's an annuity question with 2 parts. Right, or a deferred annuity, if you remember. So a deferred annuity is where we've got some initial amount that we've invested, and then in our case, right, for here and on the final, I'm going to get you to figure out how long do we have to wait until we can get payments of some amount, right? It's essentially the same as the one we just did, but just lobbing off this part, right? And so now I'm saying, okay, well, you've invested this amount. How long does it have to sit there until we can get these payments? So you guys all got that though, right? DAMAN. Thank you. So Ernie currently has $40,000 in his RRSP. He'll let it collect interest at a rate of 3% compounded monthly. So he'll retire when he has enough money to purchase an annuity that pays $1,500 at the beginning of each month for 20 years. while money earns 6% compounded weekly. Uh-oh. So now we've got these two interest rates that we need to keep track of. Okay. How long will Ernie need to wait until he can retire? Okay. So let's just start mapping it out here. So let's say today, and then at some unknown time point, I guess he's going to retire. Looks like refires. And then he needs these payments to last him for 20 years. I'll put plus 20 years, right? Retirement plus 20 years. Only because we don't know, the whole goal of this operation is to figure out the length of time between today and retirement. Right, so without a reference point, right, we can just say plus 20. Yeah. Okay. So we know he's got this 40,000, and it's going to sit there until it can sustain payments. So it's going to become some future value, and I'll make that maybe not future value 1, because it's actually going to be I won't put my subscripts on quite yet. You'll see why. So it's going to sit there until it's some future value. Right? And then we want to get payments, $1,500 at the beginning of each month. So here we've got 1 month, 2 months, and then 20 years, 240 months, 239 months. And so we know at the beginning of each month, meaning we have an annuity due. So at the beginning of each month, so that means we have to get a payment of $1,500 today, a payment of $1,500 at 1 month, $1,500 at 2 months, and the last $1,500 at 239. These are all going to funnel back to some present value due. And we can find that amount. And then these have to be the same. So if you want to put subscripts on, you can, 1 and 2. But if you don't want to, you don't really have to, because they're the same number, right? And then the whole goal is to figure out what the length of this arrow is, right? The length between 40,000 growing to what it needs to be, right, at future value 2. And then once we have, so our gateway, right, is finding n, and then we can find time, right? Regardless of the scenario. We have to find n first, and then we can find time. Okay. So on here, we know that n is 240 because we already calculated it for the ticks. Okay. So we do need to make a note of our different rates. Right? So the first section has an interest rate of 3% compounded monthly. And the second section has payments at the beginning of each month. And the payments per year is 12 month, I just said. And the compoundings per year. 6% compounded weekly. And R is 0.06. We could do these by hand. We could do them on our calculator. Which do you prefer? You're allowed to do both on the test, just out of curiosity. Okay, sounds good. Yeah, I think I actually just automatically started doing it by hand yesterday. So I kind of accidentally made them do it by hand. But yeah, you should use your calculator probably. So let's just do that because it's easier. So first, find the present value due. So you've got N, you've got interest per year, you've got a present value, you've got a payment amount. You've got a future value, payments per year, compoundings per year, and beginning or end. So again, we're working from right to left. So our N here is 240. Our interest per year for this section is 6. Our present value is what we're trying to find. Our payments are 1,500. Our future value is 0, right? Once we've ran out of monies, we don't have any left. Payments per year, 12. Compoundings per year, 52. And we're at the beginning. So we have to change that. Unless you're already in beginning mode. Oh, we are. Where I am. So 240 for N. 6 for interest per year. 1,500. And that payment's positive, right? Because we're getting these payments. 0 future value. 12, enter. 52, enter. Compute present value. Get a present value of -210, 224.4794. So therefore, we need to know the time it takes for 40,000 to grow to 210,000. For 40,000 to grow to 210,224.48. It's not looking good. Especially because the rate is less, 3% compounded monthly. So can use our calculator again, and interest per year, present value payments, future value payments per year, compoundings per year, beginning or end. I'm going to leave it in the beginning for this one because I don't think it matters because we don't have any payments. So it wouldn't recognize it. But I'm curious. So N is what we're trying to find, right? How many compoundings is this going to take? That'll get us to how long is this going to take? So our interest per year for this one is 3%. 3% compounded monthly. And because we have this just kind of regular compound interest, right? Payments per year and compoundings per year have to be the same. And I'll say end, but I'm actually going to keep it in beginning mode just to try it out. Okay. The future value that we need is 210,224.48. Payments we're making is 0. And we're investing 40,000. I'll make that negative. So for these regular compound interest problems, just as long as one of the future value or the present value is negative, the other one's positive, it's going to work out. So 3 interest per year. 40,000 negative present value, 0 for the payment, 210,224.48 future value. 12, and compute n. What do I get? Same thing here. Yeah, so it turns out this one doesn't matter. So, because I did it with beginning and it didn't change the number. Yeah, so the n, yeah, because I've got it as the end, but here I'll change it to end mode, compute. Yeah, it's still the same. So regardless of which beginning or end mode you're in, and we get 664.5478862. Oops. Just a little note, right? Keeping track of, this is the number of compoundings. Number of compoundings. We would need 665 compoundings, right? So we have to always round up. So even if it was 664.01, we would still have to go for 665 because just 664 wouldn't quite get us there. Right? So same thing we've been doing. So 665 compoundings. And then we can say n is time times the frequency. N is 665 times what we're trying to find. And the frequency, the compounding frequency was monthly. So 665 divided by 12, I get a time of 55.416 repeating. It would take, or I guess he can retire and it doesn't matter. It would take 55.42 years-ish. So he has to wait 55 years, 55 and a half-ish years to retire. Cool. So I made it negative because in theory, he would take the amount that he has in his RRSP and just invest it. So like so we think of it as he has it, but he would give it to the bank, right? And say, here, hold this for this amount of time, right? But for this one, it actually doesn't matter. Yeah. Did you guys get your assignments back before you take off? right. Any other questions? No? Last one. You can do it. And it's potentially your favorite one. Or maybe not. I'm teasing. Teasing, teasing. Should look very familiar, right? To the written assignment 3 that you did. This is just a mortgage question. So you purchase a $500,000 home in Kelowna, and you're going to make a 10% down payment and repay the remainder of the mortgage at a rate of 3.9% compounded quarterly. Okay, fair enough. Part A, calculate your end of month payment if your amortization period is 25 years. Okay. So we have to find our payment amount. I'm just going to put them into the table. I use the calculator to find the payment amount. Right. So N interest per year, present value payment amount, future value, payments per year, compoundings per year. Oops, beginning or end. Okay. So, all right, where do we want to start? So let's start with the down payment and subtract that from the 500,000. So that's going to be our present value, right? So we've got 500,000 times 0.1 is 50,000. So we've got 450,000. I'll just make a note here. That's 500,000 minus 50,000 down payment. We're trying to find the payment amount. When we're all done paying this off, the future value has to be 0. And we're making end of the month. So payments per year is 12. And the interest rate is 3.9% compounded quarterly. So we need to find N if our payments per year is 12. 12 for 25 years, we have 300 payments. Uh, 3.9 interest per year, 450,000 present value, 0 future value, 12 and 4, enter. And we're at the end, just double check and then compute your payment amount. Get a payment of -2,347.375904. Therefore, the payments are $2,347.38. One thing we do need to calculate is I2, right? Because that's how we find our interest amounts. So R1 is 0.039 and our F1, which is our compoundings per year, is 4. I1 is 0.039 over 4. 0.00975. So I2 then, 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.00975 to the power of F1, which is 4 over, what's our payments per year? Nice. Thank you. Plus 1 to the power of 4 over 12 minus 1.003239494. Store that somewhere safe. Call it 1. Although Braden in the other class, he told me that he stores I2 in 0. What? I know, let it sink in. I was like, how? It's so far away. Yeah, I know. All right, now the fun part. Now we just fill in the table, right? So we want the, you know what, I'm gonna steal this and then I'm gonna try to make this table as big as I can because I keep running out of room.
This is all off the test that that's online.
Mm-hmm.
So we need to get it.
No, because it's 13 pages, so I didn't print it off. Yeah. Especially because I wasn't sure how many to print. But yeah. That's nice and big. All right. So we'll do, together we'll do just some choice rows. How about? We're not gonna do all of them. Okay. Oh. Our first row always starts with payment 0, patient 0. And then we don't know anything except for the original balance of what we borrowed. In this case, 450,000. And then we need to figure out our total number of payments. We already decided was 300, right? So this table is going to go to 300. And we're asked to find, so construct a partial amortization table for the first and second payments. Okay, fine. Done. The 250th and the 251st, but to find the 250th row, you need the 249th row, right? So we need to find the future value at 249. So here I'm going to put 249 and then 250, 251. Done. And then the final two payments, which is the 300 and the 299. But in order to get the 299 row, I need the 298 future value. It's almost like I designed this table just for this. Couple dots in there. So we know our payment amount is 2347.38. And whatever you want to do to indicate that it's the same until this 299th payment. Right, that last payment, we have to figure out what it's going to be. Right. But between then and there, it's just 2347.38. Although I'm tempted to draw a line just showing, oh yeah, they're all the same. But I would hate for someone to go back and look at these notes and go, well, what's happening here? Well, I'll write them out, but you don't have to. You can just show they're all the same. Use ditto marks if you want. Okay. So our interest amount, right, is the balance, the previous balance times I2. So we've got I2 stored in 1. So times 450,000. 1,457.77. I feel like all term I've been nagging you guys, keep all your decimal places, keep all your decimal places. And now I'm going to change my tune and say you have to round to 2 decimal places, right? Because we're talking money here. The principal amount is the payment minus the interest amount. So 2347.38 minus 1457.77. So the amount that we get to pay off of our loan is $889.61. So we take that off of 450,000. Oops, lost it. I tried to get clever and start storing the previous balance because you have to use it later on. And of course you can, but I kind of found it was tricky to keep track of where I had stored stuff. So I'll fill in that next row later. But for now, let's figure out what the present or the future value is of 249. So we need future value at payment number 249. And you don't have to show work for this on the final. On the assignment, I wanted to see it, but on the final, you don't have to show it. You can just put it in if you want to. It's more if you do it wrong and you want to get part marks, or you think you did it wrong, and then I can give you part marks. Okay, here we go again. And interest per year, present value, payment amount, future value, payments per year, compoundings per year, beginning or end. And we're going to force to be 249. What was the interest per year? 3.9. Thank you. Present value is the 450,000. The payment amount is negative 2347.38. Here's one of those instances where it's important that we have the negative, right? Because otherwise we're trying to find the future value where first we borrowed 450,000, and then every month we kept borrowing $2,347, right? If we had it positive. So that's why we have to have a negative, so it's actually chipping away. Then that future value would be huge, right? If you keep borrowing money, then your future value, how much you have to pay back, is going to be huge. So this is one we want to find, and our payments per year are the same, and I can't remember at all, 12 and 4 and. I'll cheat a little bit. Negative 110, 184, even? Is that what you guys are getting? I just have it on the sheet here. Yeah. Phew, nice. So then that's our balance here. 110, oh, 184.00. So from there, we can find our interest amount, 110,184.00 times recall 1, 356.94. So 2,347.38 minus 356.94, 199.44, 184 minus 108, 193.56. I'll leave that next one too. I'll fill it in before I post the notes. And so now, here, again, we need the future value at payment number 298. So if you have all this in your calculator, right, the only thing that changes is n is 298. Everything else stays the same. I get 4,669.99. Just stealing it from my sheet here. Technically negative, right? We would have to pay, if we decided to just square up, we would have to pay 4,669.99 at the 298th payment. $469.99. It's on sale. 4,669. I made it really on sale. Times I2, which is in recall 1. I get $15 in interest, 0.13 cents with rounding. 2347.38 minus 1513. We get to pay 2,335, or sorry, that could have mucked things up real bad. Take that away from the 4,669.99. 2,337.74 is the last amount owing. Right? These things wouldn't work if the balance at the end wasn't zero, right? But we know we have to pay off the 2,337.74, right, as the balance. But we also have to pay interest on that, so times I2. So we have to pay $757 in interest. And so our last payment has to be $757 plus $2,337.74. So our last payment is $2,345.31. Notice that it's different. It's always going to be in the ballpark, roughly, but it will be a little bit different. Oh, and then the last little bit here. What was the total amount of interest paid on the mortgage? So we have to figure out, right? So the total interest paid is the total paid minus total borrowed. Oh. Maybe I'll say total owed. It's shorter. So the total paid is, there were 299 payments of 2,347.38 plus that last payment, right? So just finding out the total paid, just like you did on the assignment, 2345.31. Minus 450,000. Times 2,347.38. I get 704,211.93 minus 450,000. Oops. 254,211.93.
Like every house you buy, it just costs you double.
Basically. Yeah. Just, you're paying double. You did it. That's it. You just master these concepts. You've got it. Nice. So I'm around sort of 11th, 12th, and then the afternoon of the 17th. That's more kind of applicable to you guys, and all day on the 18th. Cool. Good luck on your first few finals. I'm guessing I'm at the end of your schedule. Yeah.